Our Vancouver family has now moved on to part 2, where they are going to optimize their storage. Before diving into the spreadsheet tool, let's pull up the step-by-step process. Notice the cyclical or iterative nature, and until you have an acceptable design, you'll go round and round, adjusting catchment area, storage volume, or your demands. It's about balancing your supply and demand, making sure that you don't run out of rainwater for any given month. But you don't want to just balance your system, you want to balance your system for the least possible cost, i.e. the smallest storage capacity. That's called optimizing. Now let me walk you through this diagram. In part 1, the goal was to define your supply and your demand. And remember, you really always want to start with critically evaluating your demands. So assuming you've done that, you end up in part 2, and you start part 2 with back solving storage capacity. That means finding the storage capacity that works for the demand and the supply you've defined in part 1. If right off the bat you find a storage volume that is affordable and fits in the space you have, you can go straight on to part 3. But often that's not the case. So the first thing you should do is ask yourself, can I increase my catchment? And if you can increase your catchment, do that first. And if you can't increase your catchment, you'll end up at a decision diamond, shown on the diagram as which approach. And you have 2 options. You can either go back and reevaluate your demands, reducing your demands, most likely, and then re-back solve for the new storage capacity with your reduced demands. Again asking yourself if you have an acceptable design. Alternatively, going back to the decision diamond, which approach, you could say, I have a budget and I can fit this size of storage tank. So you could do some research and find out what sizes of tanks are commercially available, plug that into your model, and then go and figure out, back solve, what demand volumes that storage capacity will allow you to have. Then ask yourself, is my design acceptable? So until you have an acceptable design, you'll go round and round, adjusting catchment area, storage volume, or your demands. And the diagram just helps you do this in a very logical order. Now let's go and apply this thinking and this thought process to our example in Vancouver. Starting at step 2.1, back solve storage capacity. We're going to input an estimated storage capacity volume. And a quick way to do that is to look at the demand from your 3 largest months, although it's quite conservative, 64,000. So let's do 64, 1, 2, 3. Now the tool is really neat because you can pick a different commission month, and you can see that it's really quite logical in our climate that you might commission something like this in May. But to match the example in the book, we're just going to leave it at January. The minimum stored volume is the minimum amount of volume you might leave in the tank. What this does in the spreadsheet is that the spreadsheet will highlight in kind of this warning color any month-end volumes that are below the amount you've defined in your minimum stored volume. We're going to leave it at 0 for now as we go through this exercise, but you might set it at 10% of your total storage volume or something like that, depending on your needs and your context. If you knew the actual dimensions of your tank, you could use this cell to input the volume you need to keep in your tank to keep that 4 to 6 inches or 100 to 150 millimeters of minimum volume. And that's about not disturbing your sludge. For this example, though, I'm just going to leave the minimum stored volume at 0. And then your initial tank charge, what you can do is you can set your initial tank charge equal to your storage capacity. And this just means that you start off with full volumes instead of starting off with 0, right? And having to wait until it fills. So that can make a difference if you know you're going to fill your tank right off the bat or not, right? In this example, to match the example, they put 0. So now, with our first estimate of 64,000, the Vancouver family looks at the resulting storage performance in these columns. There are no months in years 1 to 4 with 0 volume. So we are going to lower the storage capacity in smaller increments. What we've just done is we've iterated for the smallest storage capacity that will balance our system. Now, the Vancouver family needs to ask themselves, is the design acceptable? They pull out a page from a catalog from their local rainwater tank supplier, and they see that the largest tank size is 35,000 liters, or almost 36,000 liters. And that tank has a 141-inch diameter and a 160-inch height. So that's 12 feet in diameter and even more than that in height, or 3.5 meters in diameter. They know that this is way too big and way beyond the space constraints they have. So they move on and consider the possibility of increasing the size of their catchment. They are planning on building a garage and realize that they could include the garage roof as part of their catchment. So, knowing that their garage footprint is 55 meters squared, they can actually adjust their roof area in this tab without having to go back to the Part 1 tab. There's the catchment being used in the calculations. So now they can back solve again, right? So let's go 50, 5, 40, oops, 0,500, 0,800, there we go, 0,700, okay, 4,0,800, it's pretty small, okay. They are now at a tank volume just above 40,000 liters. Let's bring back up our process diagram. They've just increased catchment and then back solved for storage capacity, but this tank size is still too large. Now they have to decide, are they going to reduce demand or set storage and back solve demand? They decide to reevaluate their demand needs. After considering how conservative the calculation methodology is in Part 1 for outdoor landscape irrigation, they decide to reduce their outdoor water demands to 50% of what was calculated by the original Step 1.5 methodology. Let's go back to the Part 2 tab and back solve storage capacity once again. The minimum storage capacity that results in a balanced system is now substantially lower than before, at 10,700 liters, and they are finally at a tank size that is within their budget expectations. They also noticed that if they increase the tank size to 15,140 liters, which is a 4,000 gallon tank, they end up with a minimum stored volume of over 4,000 liters in the month of September. They are finally happy with their design and ready to move on to part 3.